In system test, somebody has to start the execution of automated tests on the right build, on the right test bench, and collect the results. If automation is done right, this can happen many times a week or even a day. Doing that by hand does not really scale, especially once branches, variants, and test stages stack up in numbers. Jenkins is the open source automation server that has carried this orchestration job for most teams for over a long time already. The video covers what Jenkins is and what role it plays inside of system test. Jenkins is an automation server that runs so-called jobs on a schedule or on a trigger or on demand. Jenkins has a web interface, but also a REST API and a large plugin ecosystem. Jenkins in general runs so-called jobs. A job is just a sequence of steps. So for example, checking out code, run a script, and collect results. Modern Jenkins jobs are pipelines, so written as code in a file called Jenkins file. That file lives in the repository, versioned together with the software and the test script. The key mental model here is that Jenkins is kind of a conductor of work. So it does it not by itself, but it triggers, schedules, executes, collects data, and reports the results. Jenkins sits in between a build pipeline and the test infrastructure. So a developer commits code, a build is produced, and Jenkins then picks it up and executes the automated tests that are associated with it. A typical system test pipeline pulls the build from the right branch, claims a test bench to execute them, or uses hardware in the loop, deploys the software, and then runs the tests and pushes the results into the test management tool. So that's the ideal scenario. One important detail is that Jenkins is also connected to real hardware. What system test actually gets out of this is very valuable, because every test run is anchored to a specific build and branch, which makes it traceable and repeatable. There are some challenges to be aware of. The first is treating Jenkins as the test tool itself. That's not the case. A green pipeline with weak tests is still a weak test coverage. The second are flaky pipelines. Intermittent failure that nobody investigates poisons the trust in the whole system. So a flaky test must be fixed or archived. The third is a diverse plugin landscape. Too many plugins can be pretty overwhelming and also lead to fragile builds and a fragile infrastructure. The fourth challenge is hardware agents as bottlenecks. If there's only one bench or a critical variant available, every job queues behind that. So you have to plan the resources of the test infrastructure properly. Another challenge is the reporting. So it is an issue if the results never leave Jenkins itself. It is important that the test management system in the end, who is the master, gets the results from Jenkins. And the last challenge is over-engineered pipelines. A Jenkins file that only one person understands is a single point of failure. So rather keep it simple. So Jenkins is the conductor of system test execution. It does not do the test itself, but it orchestrates and it ties everyone to a specific build, branch, and agent. If that is done right, the results are traceable, repeatable, and trusted.